Good morning. We're here on April 1st, 2025 in Mountain View, California at the Computer History Museum with Ned Barnholt, former HP and Agilent employee. And Ned, welcome to this CHM today.
Thank you. Nice to be here.
We're so happy to have you here because you were responsible for some of the most important transitions at HP and Agilent, which became Keysight, of course, later on. And so we're going to get into that quite a bit later on. But for now, could you tell us a bit about your early home life and what your folks did, where you grew up, that kind of thing?
Well, I actually was born in New York City in Manhattan. My father was a civil engineer, graduated from Drexel and worked on the Long Island Parkway system when he got out of school. So we lived in Long Island the first few years of my life. Then he was on the Manhattan Project. So we moved to Oak Ridge, Tennessee for a couple of years. I don't remember anything about that, but I know I was there when I was 1 and 2 or something, and then moved back to New Jersey. And my dad continued in civil engineering, and then 1955, when I was 12, he decided to uproot the family, which was me. I was an only child and my mother, to California. He had taken a job helping to build a nuclear power system in Pleasanton, California. And so we moved out here. I went to, ended up in North Hillsborough, ended up in Burlingame High School, and had a lot of great memories there in my early years. But
can I interrupt just for a second? I'm curious about the two things, both atomic.
Yeah.
One is you mentioned he worked on the Manhattan Project, and then later he worked at Livermore National Labs, or
he worked at a startup company that was going to build nuclear power plants. And again, his job, even in Oak Ridge, was never the nuclear side. He was more on the building side, the construction side. But this company that he ended up joining in Pleasanton was going to build in the very early days of nuclear power reactors. That company didn't last more than a couple years, but fortunately, General Electric had their nuclear power division in San Jose. So my dad ended up working for GE Nuclear Power and ended up being responsible for a lot of their new power plants that they built in Europe and around the world. So
that's interesting because there's actually a nuclear power plant, I believe, by GE on the way to Livermore if you drive up there.
Yes.
Do I have that right?
Yes. Yeah. In fact, I think that was one of the earlier ones that was built. And I don't remember if it was part of this company or not, or it was just, or if it was built by GE. It was operated obviously by one of the power companies, but I don't know what GE's involvement was in that. But anyway, I had a wonderful childhood. My dad being an engineer was great because whenever we go on trips, we'd have to stop and see how every bridge and dam was built. So it started me off on a path towards science and engineering at a very early age.
Did it give you a sense, a lot of engineers have this sense of mastery over the physical world. And did you get the sense that this would give you kind of a power over
I never got the
your
sense
environment
of power. It just gave me a sense of knowing how things worked.
Exactly. That's what I meant.
I just felt comfortable having, a better idea how the world actually worked. And that, to me, satisfied my curiosity and, again, my desire to continue to do that later on when I went to college. So I grew up, I went to Burlingame High School. I was very, very fortunate there in that I was able to take a lot of math classes and things, but I also had a lot of leadership experiences. Some friends of mine talked me into running for class president when I was a freshman. So I was sophomore year class president. I was shocked that I won, but I ran and gave a speech, and I guess people liked it, so I ended up being sophomore class president. And then junior class president and senior class president. So I had, and then student body president. So I had a lot of leadership experiences at Burlingame High School.
And then following up on that, you were also in the Scouts as well.
I was also a Scout. I was started in Scouts in the East Coast, continued on in California, became an Eagle Scout, got my silver palm. I was a Silver Explorer. Scouts was another place that I really learned leadership. When I worked at a Scout camp one summer, and I had to lead a bunch of young kids, and I remember I was probably 14 or so, 15, but I had to lead a bunch of young kids on hikes out in the woods and bring them back. And I just remember enjoying the responsibility, enjoying the idea of getting the group working together as a team and accomplishing our goal of completing the hike. So I had a lot of leadership opportunities when I was young, which I think helped kind of pave the way for me later on in life. So I give a lot of credit to my parents, for letting me do all that stuff, and to scouting, and to the opportunities I had at Burlingame High School.
Right. Now, there was a 7th grade teacher that I believe influenced you as well, right?
Yeah. When I first came out to California, I was in 7th grade, and I really hadn't found my way yet in school. I wasn't a big fan of school when I was back east. I would much rather be out on the ball diamond playing baseball or shooting baskets or doing something. So my life, my interest at that point was all about sports. And so it was later on that I began to understand the importance of studying. But it was a 7th grade teacher that literally took me by the collar one day after, I don't know, 4 months of being in his class. He took me aside and said, "Ned, I'm really disappointed in you. I know you can do a lot better. You just have to work a little bit harder and get your homework done, first step, and make sure that you're studying to continue to learn more and more." And I did, and from basically 8th grade on, I was a pretty good student. So he really got me focused in the right direction. My parents did too. I mean, they were all over me, but it was the 7th grade teacher that I remember just calling me out in class, saying, "I know you can do better."
And what was his name?
Sam Burney. Yeah, Sam Burney. He was an elderly teacher at the time. He'd probably been teaching 30 years when I had him, but he was just a wonderful role model. He was just a nice human being and very, very curious. I mean, he was also one that made learning fun. It was not just memorizing things in the book. It was understanding things and exploring, and in a new and creative way. So, perfect teacher.
Yeah, amazing what a difference even just one good teacher in your life can make.
Right.
Yeah.
Of course, I married a teacher, so
there you go.
she keeps me learning all the time.
Right. So tell us about college, if you're done with high school.
Sure.
And what that was like.
Yeah, college. I went to Stanford. I knew I wanted to be an engineer. And by the way, first of all, I wasn't. My advisor in high school told me, "Don't even bother trying to get in Stanford," because I actually had 1B in high school or something. He said, "You'll probably never get in." And so but I said, "I'm going to try anyway." And fortunately, I ended up getting in, but I had looked at a lot of other schools as well, including Berkeley. Great schools. But anyway, I felt lucky to be at Stanford, and I didn't know what I wanted to do. I started off in mechanical engineering. And then after a couple semesters or quarters, I changed to aeronautical engineering, or 1 quarter, I guess, aeronautical engineering. And then in my 3rd quarter, I changed to electrical engineering, because we had at Stanford at that point, you had to take a breadth course in a number of different areas. So my very first introduction to electronics class, I'll never forget a teacher there, a gentleman named Jim Gibbons, who ultimately became the dean of engineering and ultimately the provost at Stanford. He was my advisor in my graduate year. But Jim walked into the class with a box of vacuum tubes and said, "See this? This is the way electronics used to work. See this?" He showed a transistor. "This is the future. We're not going to talk about that. We're only going to talk about that." So I got really fired up about semiconductors and learning about electronics. So I switched my major by the end of my freshman year to electronics.
By the way, is it fair to say that you did not learn vacuum tube theory? I'm sure you know how they work, but you weren't trained as part of the curriculum in vacuum tubes. The schools had already moved on to
They did,
state.
although there were still some classes at Stanford that were radio engineering type classes.
Oh, microwaves and stuff.
Yeah, that were more vacuum tube related. Right. And I remember taking one of those. But no, most of my courses, I'd say 90% of the courses were all around solid state. But that was very early days. I mean, these were germanium PMP transistors, which was, very, very early days of.
Would you say that were point contact, or were they junction at that point?
I think they might have been junction, but I can't say for sure. This was 1961, so.
Junction, yeah, whatever. Probably, yeah.
So, but anyway, I did continued on with electrical engineering while I was at Stanford. Frankly, I really found that I had to study hard. And once when you get into a school like Stanford, and there's so many great people, I learned so much. I tell people I learned half of what I learned in college was from other students. We in the dorm, and just at night meeting with friends. You just sit around and talk and solve the world's problems, and it was such a wonderful experience. And but I didn't do anything leadership-wise. I didn't do anything other than just study, and did a little bit of intramural sports. But
that sounds like engineering.
Yeah.
All you do is study.
Yeah. My friends were out, on Saturdays partying or getting ready for the football, and I had a lab to go to, or I had problem sets I had to do, and so it was a lot of work. But again, I really appreciate Stanford's approach. A lot of schools at that point in time were teaching kids how to design amplifiers or oscillators or whatever, and they said, okay, if you need to design an amplifier, here's a design that works. And Stanford never did that. They basically said, okay, let's step back and say, what are you trying to accomplish? What are the different ways you can do an amplifier? And which was great, because the technology changed so fast. You need to be prepared for doing it a different way than what was in the textbook 2 years ago. So I really appreciate how Stanford taught engineering and prepared me for what was out there in the world, which was a very, very fast-moving world at that time.
Yes, exactly. And tell us, so you finished your bachelor's in...
Yeah, so I ended up with a bachelor's in electrical engineering, and I decided at that point that I wasn't one of those people that grew up building radios and playing with electronics. A lot of the people that were in the engineering program were like that. And I just felt that I really wasn't prepared to go into the real world and take on a job. So I decided to stay an extra year and get a master's degree. And at that point, I don't even remember applying. I just said I'd like to be an extra year. And at that point, I think I just stayed on. And Jim Gibbons was my advisor for that year, and I did some research, but mostly just took additional classes. And then I graduated. It took me until the fall quarter of 1965, or 66, I mean. And so I finally ended up getting my master's in, I officially got the degree in June of 67, but I finished in December of 66. But
do you remember what your topic was? You mentioned research.
it wasn't really research in the sense. It was just designing a very simple a stereo amplifier, power amplifier, and it was just using the technology to try to make the world's best stereo amplifier.
I'm smiling because, which of course no one can see, because I know there's a story later on at HP involving, I think, Bill's stereo.
Bill stereo. Yes.
We can come to that later if you want,
Okay.
or you can tell it now, whatever you prefer.
But anyway, so I finished my master's degree, but it was an interesting story. It was at the height of the Vietnam War, but I decided that when I got an offer from HP, I looked at Motorola, I looked at AT&T, I looked at TI, and every place I went and interviewed, it either snowed or was some terrible weather. And I actually hadn't interviewed with HP on campus because I decided I wanted to live somewhere else for a while just to try it. But I decided after visiting these other places that I really did like to stay in California. So I called a friend of mine who had got a job at a company I hadn't heard of before, say, "Where is it you work?" He said, "Hewlett-Packard." Oh, I said, "Is that the one that makes the instruments that we used in our lab?" And he says, "Yeah." "How's the company?" "It's great." So he got me an interview, and I ended up joining. And I was originally supposed to start as soon as I graduated in December of '66. But I decided I wanted to do a little skiing in the break there before I started. So I told them I'd start in April. Literally the day after I graduated, the draft board called me and said, "What are you doing now?" And my number, I was San Mateo County, I was number 12 in the lottery, so I knew I was going to go. So I said, "Well, I'm working at Hewlett-Packard." So I hung up. I called Hewlett-Packard and said, "Can I start next week?" And sure enough, I started in December of '66. And at that point, HP was about 200 million in revenue and about 3,000 or 4,000 employees. I can't remember exactly. And I started in the lab. I was designing signal generators. And in fact,
their original product.
One of the first projects I worked on was a decade oscillator where they had one oscillator that went from 10 to 100 megahertz, one from 100 to a gigahertz, and then one from a gigahertz to 2 gigahertz or 3 gigahertz, whatever. And I worked on the 10 to 100 or one, and turned out I had to look at Bill Hewlett's audio oscillator paper in process of doing that because I was designing some of the audio part of that as well. So anyway, I went and talked to Bill Hewlett about his paper shortly after I joined HP. But anyway, that was my first project, and I worked on several other signal generators. I worked on a network analyzer, early days of network analyzers.
Just to back up a bit, can you tell us about the interview process? Because I think that's kind of interesting. You mentioned there's actually an exam, right?
Well, yeah, the interview process at HP was very intense. So you basically I came in and I met with, I think, 4 or 5 people, 6 people during the day. But one of the persons that I interviewed was to give me the technical exam. And he started off at his desk with a stack of papers about this high. And he started asking me questions. And I remember the first one was pretty easy. Second one started getting harder. Third one was starting to get really hard. And he still had a stack of papers to go. So I said, wow, but evidently I must have done okay.
Wow. So how many questions in total would you say?
I think I had probably had 10 or 12 different questions or something like that. But so anyway, that was an interesting process. And at the time I started, I really didn't know. I just assumed I would be an R&D engineer. But one of the persons that interviewed me was in marketing. And at that point, product marketing was very new. Not a lot of people were doing product marketing with an engineering background. But he talked me into eventually potentially considering a job in marketing because maybe my leadership background, or I liked people. I didn't want to spend my life on my workbench. So I ended up with a joint offer from marketing in the lab with the understanding I'd spend at least 2 years in the lab and then potentially move to marketing. Well, that 2 years turned out to 3 or 4 because every time I wanted to transfer to marketing, the lab manager says, "No, you're not. I need you on this project." So I ended up staying in the lab a little bit longer than I had originally planned, but it was fine. It worked. I still think that was such great experience because even when I became CEO, I could do a deep dive on the technology with engineers, and most of them were amazed that I could ask the questions I did. So I think it was, and I found it interesting. I really enjoyed interacting with engineers on the technology. So I really appreciate that time I spent in R&D. I think it was great.
Was there a mentoring that went on at HP?
Not really. There was no formal mentoring program. I had a friend when I joined. I was single, like most of the other people my age who had just joined. So a bunch of us got a ski cabin together at Squaw Valley. Some of us went river rafting up in the Russian River. So we do a bunch of stuff, together. And one of the friends that I got to know pretty well was Doug Chance, who became the marketing manager at Microwave. He was in manufacturing initially, and then he became the marketing manager. And he was the one who ultimately recruited me over to marketing. And I don't think he was official mentor, but it was interesting. After spending a couple months in marketing, he said, "Ned, you need to learn more about customers. You're coming at marketing from a product point of view." So he sent me out into the sales organization to call on customers and to be a sales support person at that point it was the LA sales office. And I'll never forget the very, very first question I got from a customer. He said, "I'm building a microwave oven, and I want to know what the VSWR difference is between a turkey and a roast beef and a pork chop in a microwave oven. Can you help me calculate that?" So anyway, after that, I realized, customers have a lot of different ideas, and so I really became much more customer centric in my approach and how I have thought about problems and what customers might be looking for and stuff. So, but that was a great experience. So he was kind of a mentor in the very early days that helped me kind of get acclimated to the marketing world. But then he went off to be a general manager at Santa Rosa. I think one of the after I moved to marketing in the early 70s, the microwave division split. Bill Hewlett and Dave Packard had this idea that as divisions got to $100 million, they ought to split and go off and look at what they need to do to each get back to $100 million. And so we, at that point, microwave division had gotten to 100, and they decided to split and take all of the network analyzer and spectrum analyzer things to some other site. So my wife and I were asked to go evaluate sites. So we went to Albuquerque, New Mexico. This was in the early 70s. We went to Medford, Oregon, and we went to Santa Rosa. And the reason that we were on it, partly they wanted a perspective of a young engineer, but also my wife was a teacher. So when we went to these places, we looked at their education system and talked to some of the people in the education area. So when we came back, I was part of a team. Different people looked at different aspects of the community. there was, I don't know, 10 or 12 of us. So when we came back, we all picked Santa Rosa as the site that we thought made the most sense.
Can you tell our viewers where Santa Rosa is in California?
Well, Santa Rosa is about an hour north, an hour and a half north of San Francisco. So it's up in the wine country. It's up in beyond
Marin.
Marin, yeah. It's a little bit further north. At the time, it was pretty remote.
Yeah.
But it had a couple things. One, it had a junior college. It had a small little private airport, but we could fly small, planes into it, and private planes. So anyway, it was close to San Francisco. It was close to the Bay Area, and ultimately it just took off. I mean, Santa Rosa today is a big thriving community, but HP was the catalyst that I think got all that started.
Well, what were the initial products built at Santa Rosa? Do you recall?
Initial products were spectrum analyzers and network analyzers. Pretty complex stuff. And we moved up we had a thin film manufacturing facility. A lot of the microwave products at the time were on sapphire substrates, with etchings and, different components attached and everything. And that was a very, one of the more complicated and critical parts of the product. And so that moved up to Santa Rosa as well as some gallium arsenide manufacturing. At that point, we did some gallium arsenide semiconductor work, and then it did it for quite a while.
Now, this is HP making its own?
HP, again, for high-frequency applications, gallium arsenide was an excellent way to go.
But you actually fabbed your own gallium?
We had our own gallium arsenide facility. And it was very successful, and I don't know if they may still even have it. I mean, even 20 years ago, we still have it. So you can't, a lot of the things we needed, you can't buy on the open market because nobody wants to build it unless it's a big commercial, it has a lot of volume. Well, we weren't doing things with a lot of volume. We needed things that just did the job.
In fact, there's a lovely scope that I dream about. It's the 30 gigahertz digital sampling oscilloscope, which is it's $1 million.
Is that right?
The scope.
Yeah.
From Agilent.
Right.
Yeah.
And that's exactly right because it has all the components that nobody else wants to make. And so that was so all that went to Santa Rosa, but it turns out my background, both in the lab and in my marketing days, was mostly on the signal generator side, sweep oscillators and RF and microwave signal generators. So at the last minute, while they were deciding who goes to Santa Rosa and who stayed, they asked me to stay because I was one of the few people that knew anything about the product lines that were going to stay in Palo Alto.
Now, was this being as a marketing?
I was a marketing product manager. Then I became at that point, I became the product marketing manager for all the different products. And then I did that for a couple years, and then I went down to Santa Clara division as the marketing manager, which was yet another set of businesses. Santa Clara made frequency counters, atomic clocks, cesium, rubidium, quartz oscillators. It made logic analyzers, we used to call it the science fair division because there was so many different different products. There was Fourier analyzers. I wasn't involved with that directly, but Fourier analyzers.
We have one of the early HP Fourier analyzers, Sabrac, about 8 feet high.
That's it. And we also had lasers for surveying, so laser interferometers. So anyways, all those were in Santa Clara division, but I was particularly involved with counters and logic analyzers and atomic clocks.
When it comes to, one of the things I admire about HP is their documentation. So, and marketing literature, which, a lot of people don't get too excited about, but I thought HP's was really well done. And, always lots of technical information, and which is what engineers want. And do you have any insight? Did you help shape how the products were presented to the public or to customers?
Well, there were two parts to that. There was the service organization, and in each marketing department, there was three parts to marketing. There was the sales part of marketing, which was basically the point of first contact for our sales organization. So if they had any questions or they need training, they needed to meet with customers, the sales people would do that. Then there was the product people who were interfacing with the lab, trying to decide what to do next, introducing new products to the market, writing the spec sheets, and the training manuals and all of those things. Then the third part was the service organization, and they were the ones who were training the service technicians on how to repair. They were working with the lab on the service strategy for the products. And those service technicians or service people were the ones that were writing the detailed manuals about how the product worked and that could be used by the service technicians in the field. The product people still wrote pretty technical manuals, but they're mostly for training purposes, talk enough about how something works, so why is this better than another way of doing it. So but the emphasis was always on the technology, making sure people, the field and the customers really understood, what it was that was unique about our products that made them so good.
I wanted to just bring up this idea of HP's reputation as just really the Mount Olympus of test equipment.
Yeah.
It was the best, the gold standard, and it still is, Agilent. And do you have any comment on the sort of philosophy that created products like that?
Well, I think it gets back to the culture of the company and what we're trying to do. Dave Packard and Bill Hewlett pounded into us from day one, we don't want to build Me Too products. We want to build products that made a contribution to the field. And so what does a contribution mean? Well, it could mean technically does something that no other product can do. That's one contribution. Another contribution is really understanding what a customer needs and doing it in a very creative and new and better way. And I would argue that HP did both. The HP products were, the first spectrum analyzers, for example. Nobody had a spectrum analyzer out there on the market. But we came up with this product that could actually show you and demonstrate to you what spectrums were in your signal. I'll never forget one of the stories. One of our salespersons went to it was either an NSA or somewhere back CIA, somewhere back east in the intelligence community, and called a friend of his and said, I'd like to show you my new spectrum analyzer. I don't have any need for a spectrum analyzer. He said, well, wait a minute. He took a little antenna and said, do you want me to tell you what signals you're working on and what the spectrum looks like for each of those signals? And the guy says, come in right away. So it was a new thing. It was something that wasn't available. And same way with network analyzers. Something that we used to call S parameters that people use to design, products. But, we built a product that gave you S parameters. So I think, doing things that customers really needed. And one of the senior executives at HP a number of years later coined a word that I felt was really good. It was IUU squared, the imaginative understanding of user needs. And to me, that was kind of the secret sauce. And very often, if you ask a customer, what do you need? They won't even tell you. They don't even know what they need. But if you spend enough time with a customer and watch how they do their job, you can figure out what you can provide them that will make their job better. And that was really kind of, to me, the key to the instrument business, is that intense understanding of measurements, and what customers' needs were. What was the barriers they were facing? If they were trying to build a high-frequency amplifier, what did they need to be able to do that? And very often, we had to build products better than what they were building.
Well, this is what I was going to get to, is how do you build like a world-leading product without a world, something that's higher accuracy or whatever?
Well, that's where the technology comes in. We had to have, our gallium arsenide facility, our thick film, thin film facilities. The HP labs gave us some novel design for DNA converters and A to D converters. So, it's a combination of that. But, you got to have innovation on the technology side, probably, to achieve that better than your customer goal.
So is it fair to say that ideas that help you identify opportunities, probably the inputs came from multiple directions, maybe your sales team and the engineer in-house, someone say, I think there's a need for this. Could you talk a bit about how potential markets or products were identified?
Well, part of it, one of the things that I think I mentioned, I was one of the earlier product marketing managers. We had sales people that were supporting the field. We had people that were supporting the salespeople. But we didn't have a lot of people that were basically from R&D going out and interfacing with customers, saying, "What do you need? What can we do what does the next generation of our product need to look like?" So that was a big part of the product marketing engineer's job, product manager's job, is to bring that market research. And I think I gave an example in my Computer World talk where I'd go out and talk to customers and I'd bring ideas back and nobody listened. And finally I realized that was my problem. I had to take ownership for that. I wasn't explaining well enough. So one of the things I did is I'd take engineers out with me to visit customers from the lab, or I would bring data back of letters or something that the customer wrote that I would take. So it wasn't just my opinion. I had facts that backed up, why I was telling the lab this is what we needed. But there's a lot of different ways. I'll give you an example. We haven't talked about Spokane yet, but Spokane was another division that split off when the division in Palo Alto was called the microwave test division.
Sorry, what year is this?
This was in 1980. So when Santa Rosa split, the division that was left behind that made basically RF and microwave sweep oscillators and signal generators had gotten to $100 million. So we split it again. And so all of the RF part of the signal generator product line went to Spokane, Washington. And I was asked to go up and be the first general manager of Spokane, Washington. And at the time, there was only 12 people. Somebody decided on Spokane, it wasn't me, and brought up a couple people. And that was it. When I arrived, there was 12 people. And all I knew is, we were going to move up maybe $30, $40 million worth of manufacturing. But it was our job to figure out how to grow the business back up to $100 million, because, at that point, the RF part was maybe $40 million or so, I don't remember. So I remember sitting around with my team, and we had all kinds of different ideas of things we could do. But I went to a trade show in Europe. There used to be a big telecom show every 4 years in Europe. It was the Olympic Games of telecommunications.
Do you remember what it was called?
It was Telcom. I don't remember if it was 81 or 82 or what the year was, 80. Somewhere in that time frame, it was Telcom. And I went to this show in Europe, and I remember seeing this device that Nokia and Ericsson were talking about. which is a cell phone. It was a phone that you could carry with you. It was untethered from the wall, and you could have a phone number and carry it with you anywhere you went. And I remember coming back and saying, wow, that's really interesting. That could be revolutionary, for the RF communications and cell phone or the telephone business. So we ended up helping Nokia and Ericsson design the test equipment to test their very first analog cell phones, which they introduced in around 1984 or 85. And from that, we helped design the equipment for the next generation. At that point, it was the 2G system. Then it was 3G, and then 4G, and 5G. Now they're working on 6G. But because of that, Agilent, which is actually, it's now the Keysight part of Agilent, probably has 70-80% of the market share for testing cell phones, because we've been working with those customers from day one to write the specs. We've worked with the FCC on the kind of specs you need for testing cell phones. We've worked with the vendors on what specs are important, so you have the kind of signals you need.
And what do you call the equipment? Is it just a test set?
Well, right now it's a I can't remember what Keysight called it. I think we used to call it a mobile or a communication test set.
Test set, yeah.
Yeah, and it combines a signal generator and an audio oscillator and an RF receiver all in one box.
I'm curious, when about the end of lifing a product.
Yeah.
So we've talked about how new products come. When and how do you decide that a product has reached the end of its life? Is it replaced by something, or maybe the sales are just not
sometimes
good?
It's pretty obvious. So the 4G, 3G products went away when 4G and 5G, and it just kind of went to a gradual decline. And when customers weren't really asking for it anymore, we kill it and move on. So sometimes it's pretty obvious like that, but very often it's not as obvious. So you just have to make a business decision. Sometimes, we would obsolete products that customers still wanted. Sometimes we would sell it. For example, we decided to get out of the atomic clock business, but we were able to sell it to, I think it was Trimble that ended up buying it. But so there was still somebody that could carry on the business, but it just didn't make sense for us. And it's a difficult decision. Sometimes we have to, because of government contracts, you have to provide spare parts for 10 years, 20 years. So, we'd have to buy a bunch of inventory and store it someplace. So you just have to do an end-of-life plan when we get to that point. But we were very thoughtful about it. We didn't want to leave customers in a lurch, because they're the same customers we want to buy our new stuff. So we didn't want to get them all upset with us. So it's very tricky.
Yeah, very interesting. Well, why don't we move on to Spokane and hear what you have to say about you were the division general manager, I think, right?
Yeah. So, as I said, in late, I think it was in the 79 and early 80s, the microwave division decided to split one more time, and they would primarily move to the RF stuff to Spokane and leave the microwave stuff in Palo Alto.
Can you just, what's the difference between microwave and RF?
It was not a clean break, but we kind of arbitrarily called it somewhere around 1 to 3 gigahertz. It started off at 1, but as our RF applications started growing, it kind of became more like 3. But somewhere in the 1 to 3 gigahertz was the general dividing point. But anyway, so I went up there as the new general manager. We were in a temporary building. We all huddled around the coffee pot every day and talk about what's going on. As I said, we started with 12 people. We probably ultimately moved up 50 to maybe close to 80 people. A lot of them in manufacturing who knew how to build stuff as we transferred products up. Some in R&D and marketing and other functions. But we were very careful. The people that we moved up were what I call culture carriers. They were people who understood the HP way. They understood how we wanted to treat people, how we wanted to, work as a team, how we wanted to have trust and respect for each other, treat our customers well, keep our employees well. So they were handpicked because they knew what they were doing, but also they were what I call culture carriers. And so we ended up bringing up a core group of people, and then we hired a lot locally as we moved up more products, as we built up our R&D capability and started growing again. Our revenue numbers started growing quite rapidly as we got into this, radio frequency or cell phone testing areas. So I ended up leaving in 2005 and asked to come back to California. But in that 5 years, when I left, we had almost 1,000 people. We had built a permanent facility. We had revenues up close to 100 million again, and so we were off and running, and things were going well.
How would you decide to move a product up to Spokane? How was that decision made?
Well, the product was based on whether it fit within this radio frequency charter that we had. Was it a signal generator or something that fit within that realm? Right. And
was the University of Washington, were there links?
Well, University of Washington is, of course, in Seattle, but
Western Washington.
Yeah, but Washington State is in Pullman, which is about an hour and a half south of Spokane. There's also a couple of really good community colleges. And then Gonzaga is there. So we actually helped. I ended up being on the Board of Regents for Gonzaga and helped them set up their engineering department. And we had our engineers go teach classes, donated equipment, and we really helped Gonzaga and Washington State, but a lot of Gonzaga started from a much lower base to really strengthen their programs so that...
Did they become feeder schools for you?
Yeah, so they became feeder schools. University of Washington, of course, was already, but and the Oregon schools to some extent. But by building it up, we gave our employees opportunities to do classes. So one of the things HP always did is encouraged its engineers to continue education. So, as I said, the technology doesn't stop when you graduate. Yeah. So, we were basically encouraged and given funds to take classes over at Stanford, at Santa Clara, Washington State, ultimately Gonzaga, University of Washington, in one of their programs, so that engineers could continue to stay up to date on the latest technologies.
We're back, and we were just talking about the local continuing education programs that HP offers and has certainly in the early days offered its engineers, a lot of them going from...
No, I think that was really important. And business. I mean, some people took business classes at Santa Clara and different things. But I wanted to come back to Spokane for a minute. Spokane was an amazing opportunity for me I was in my late 30s somehow. It's my first big management job. And going up to Spokane was really kind of frightening in many ways, because all of a sudden I realized that I'm responsible for all these people. I'm responsible for the business. And Spokane itself was a very labor-intensive town. Right across the street from us was Kaiser Aluminum, which was a strong labor company. a lot of strong labor companies in the area. My biggest fear was we'd be the first division of Hewlett-Packard to become unionized. So we spent a lot of time educating and training people as they come on board the HP way. And, of course, we had generous benefits and salaries and all that, but that was kind of given. But it was a great experience because basically we could do anything we want. And, we could organize the division the way we wanted. We could structure where we sit. We could think about all different ways of designing our manufacturing, there was no formula of how to do things. The only thing was HP was our banker. We didn't have to raise money, and we had a sales force because we didn't have to worry about, having sales as part of our division. So it was like starting your own company with HP as your banker or in Salesforce. So it was a very, very unique and fun experience. And for me, it kind of set the stage for me to do something similar at Agilent, basically starting from scratch, realizing we can do anything we wanted to do, and having, the opportunity to think out of the box a little bit and try different things and see what worked and what didn't work. So that whole Spokane experience for me was a really critical thing. And I know, a lot of other general managers at HP would say the same thing. The best job they ever had at HP was the division general manager. And they were all over. I mean, we had divisions. I mean, at the peak, we probably had close to 100 divisions, and for HP overall, including computer and printers and everything, by the late 90s. But the divisions were all, very a critical part of where everything got done, and and that's where the R&D engineers were. That's where the marketing people were. The manufacturing. We started consolidating more manufacturing later on fewer sites. But again, it was a good part of the HP success was this kind of viral split, grow. It was kind of a great thing. Now, it worked very well in the instrument business. It didn't work as well in the computer business because it's hard to split a computer system. When you have several thousand people working on a Unix operating system or on a RISC computer or whatever, it's really hard to parse that into smaller chunks. And so the model, they still did it, but it was a little different, and I struggled with it a little bit more because it wasn't quite the entrepreneurial incentive that we had in the instrument side, because you can't go off in a new division and invent a whole new computer system or a new operating system. You had to be linked to what the overall system was trying to do. So I think HP struggled later in the computer industry computer business trying to emulate that, and finally decided they really couldn't emulate it in the same way we did in the instrument business. But for the early years of the company, up until certainly in the late 90s when we split off Agilent, that model worked very well for a big piece of the company.
Mm-hmm. I'm curious because I remember feeling a little saddened when Agilent, when they spun off Agilent, I went, HP is such a revered brand, and I know fellow engineers sort of felt that too.
Yeah.
But first of all, how did the name Agilent come up with? I think you mentioned it's agile.
Yeah.
And then, did you encounter any? What were the reactions to the new name change, if any?
Well, the reaction to the split was a huge amount of sadness. We announced it in March of 1999, and there was a lot of tears, because people's identities was wrapped up in HP. Many of them had spent years and years at the company and had great regards for Dave Packard, Bill Hewlett, the culture, the HP way. And there was a lot of fear about what's going to happen. But let me back up just a little bit and tell you why we split, because I think it's important. A lot of people think it was HP just got too big. Well, it wasn't quite that simple. In the late 90s, HP's growth rate started to slow. And the board was looking at what do we do to fix that? And, McKinsey came in, gave some advice. But one of the things that I think resonated with the board was the idea that focused organizations tend to do better. We were trying to run an instrument business, a PC business, a printer business, a complex computer systems business, all with the same operating model, all under one umbrella. And, I think it makes a difference. I know it made a difference to me when we started Agilent. I didn't have to wake up in the morning thinking about how I fit into a computer company. I woke up every morning thinking about how do I optimize the instrument business. And so I think there's a subtle mental shift there, I think, that was very important. The second thing is HP was not being valued in the late 90s for its instrument business. It was all the analysts who followed HP were computer analysts. I'd go out and do, meet with investors, and their eyes would glaze over when I'd talk about 30 gigahertz oscilloscopes or something. They just, what is that? And why would you ever want to do that? So the analysts who followed us really didn't understand, the instrument business or know how to value it. And then the third reason, which I ultimately think may have been the most important, is the business models were changing. In the late 90s, the PC business was really, and the printer business was really growing pretty fast. But I remember the person who ran the PC business came into Lou Platt's staff and said, Dell and Compaq and all these PC people, they don't have a central research labs. They don't have all the employee benefits we do. They don't have the engineering salaries we do. If we want to compete with those guys, we need to get our cost structure in line with what they're doing and get rid of HP labs and lower our engineering salaries. And I'm sitting there saying, wait, time out. I want higher engineering salaries. I want more from HP labs. And so the business model really started drifting apart. And so I felt, to me, that was ultimately, for me, the most important. So part of the answer to the question about how do we talk to employees was to make sure people really understood the rationale behind this, and that we are going to be more focused. We are going to be able to, wake up every morning thinking about our business, and we're going to have our set of investors, our set of metrics only focused on our business. So, at that point, we were about 1/8 of HP revenue. So I used to tell people everything we did every morning was magnified by a factor of 8. And but that's when we set out. But people asked me what's going to be different in Agilent, and I felt in the late 90s HP had gotten a little slow, a little bureaucratic. There was a lack of accountability in terms of decisions. And so, give you an example, we had put together a team to come up with new IT systems for HP in the late 90s. And I don't know, it was 15, 20 people. And over 2 years, they really didn't come up with much of anything. So I felt the big issues I wanted to focus on was speed, focus, and accountability. We're going to be much more focused on our business, our customers, our markets, our competitors. We're going to have a greater sense of urgency to respond to their needs. We're going to be more agile and resilient in responding to our markets. And we're going to hold ourselves accountable for this times 8 factor. Everything we do gets magnified. We got to hold ourselves accountable for our results and our success, and hold each other accountable. So I went out and gave that talk, and I would guess there wasn't an employee in Agilent that didn't know SFA, speed, focus, and accountability. That was kind of our mantra. But after a month of that, an employee came up to me and says, "That's great, but that's not why I joined HP." And I realized that speed, focus, and accountability were kind of the new ideas, the new values that we were looking towards. But it's all built on a very strong foundation. And the strong foundation is all the employee values around trust, respect, teamwork, integrity. Those don't change. All the values around innovation and making a contribution, those don't change. And all the values around community, continue to be good citizens in the community. And so what I ended up saying, and people really resonated, is we're building a new Agilent based on the HP values, and we're off and running with our new company. And people started really, getting on board with that. But we did a lot of things to get people excited. So, for example, when we launched our name, I put a small group of people together to help come up with a name. We had equal number of men and women. We had people from Hispanic backgrounds, Asian backgrounds, European backgrounds, people with different languages and different cultural perspectives to help us come up with a name. And we had a branding firm, and it was fun. We had all kinds of off the wall. I can tell you sometime all the names we looked at, but it was fun. But we ended up with Agilent because Agilent resonated with the value about resilience and agility and urgency and all that kind of stuff. So we ended up with that. So when we announced the name, I invited representatives from every one of our major sites around the world to come. We had probably 200 or 300 people in San Jose at the theater downtown in San Jose. And we had a name launch. We had all kinds of fun things going on, and then we had the big reveal, and we had the name launch, and employees all over the world could kind of watch. But the people that were there, that whole week, there was a lot of things we did for employees, so they could go back and tell their employees, "Hey, this is really great. I really enjoy what's going on." And then we did it again when we did our IPO. We did a roadshow in November. My CFO and I did, I think it was 100 customer meetings in 15 cities in 2.5 weeks. It was brutal. But we ended up on the New York Stock Exchange the night before our launch. And I invited a couple hundred employees from all over the world to come and be on the floor of the New York Stock Exchange. And so when I went up to ring the bell the next morning, it wasn't my board of directors or my senior management team. There was some of those, but it was also some employees from some of our major sites that were up on the podium. And so anyway, they could go home and tell their friends, what they did. So
can you talk about since you brought up the stock exchange, the financing? You mentioned HP was, you were kind of a well-funded startup in a way, but then you went to get funding on the stock market as well.
Well, so the idea of the IPO, typically when companies split, they just dividend some percentage of their shares to their existing shareholders. Say if you're an HP shareholder, you get 0.5 shares of Agilent for every share of HP, or 5% or 10% or whatever the ratio is. We felt that was really dangerous because nobody knew us. Because all the analysts who followed HP were computer analysts. They didn't know anything about us. So the risk was if we did an IPO, people would just sell the stock and it would be a disaster. So the idea of it's called a two-step spin. If you do an IPO for less than 20% of your total number of shares, it's tax advantage. There's not a big tax penalty to do that. But it also, by doing the roadshow, we went out and met with investors who were interested in our business. We met with analysts who started covering us. So after a couple months of talking to analysts and then investors and doing the roadshow, by the time we did the IPO, there was a lot of interest in our stock. So we were supposed to open for, I think it was like between $20 and $25 a share. We opened for 30. At the end of the first day, we were 42. And so it was a very successful IPO. But again, at that point, it turned out it was 16% shares of our total, 16% of our total shares. At that point, HP still owned 84%. But the idea is we wanted a couple quarters where we did our earnings call. So the analysts could hear us on the earnings call. They could follow us. We had more meetings, individual meetings with analysts. We talk at analyst conferences. So during that first 6 months, again, we're educating the market about our business. And so when HP did the second step, which was in May, every HP shareholder got 0.31 something percent of their current HP shares in Agilent. It didn't make a ripple in the stock, so either HP or Agilent, because the people who wanted to follow us were following us, and the people who wanted to follow HP were following HP. So it really, the process worked very, very well.
Fantastic. Now, one thing I've been meaning to ask throughout this interview is your competition. Can you talk to us a bit about, I guess, Tektronix was...
Well, we've had a lot of competition in the instrument business. I mean, it depends on what business you're in. In oscilloscopes, it was all Tektronix. In frequency counters, it was Fluke. And a lot of our RF and microwave communication, it was companies like Rohde & Schwarz, it was Anritsu, Advantest, some of the international companies. So we had pretty intense competition in our electronic instruments, of course, but then Agilent was also in the medical, analytical, and component businesses. So in analytical, we had PerkinElmer, we had other companies. In medical, it was GE and Siemens. So,
and on the analytical, that's like a GC mass spec instrument?
Yes.
Yeah. Right.
And so, kind of another story, I think I mentioned once we did the separation from HP, we started looking at benchmarking our capabilities relative to everybody else and looking at our cost of the IT, our cost of manufacturing overhead, our cost of finance and HR and all that stuff. And we found we were we were way out of line. So in 2000, we launched a project we called Be Agilent. It was a project that was broken into three parts. There was Stratus, which looked at our strategy and what businesses we're in, which businesses we didn't want to be in, which businesses we wanted to be in. We needed to put more emphasis on the strategy part. There was I'm blanking on the names again, but the Vantage was the HR part of that. How's our competition lined up with, how are we lined up with competition in terms of our salaries, our bonuses? Should we have a more aggressive bonus plan or not? And then Vantage, and I think it was Stratus, I think it was Optos, was our manufacturer, looking at our operation strategy. And one of the things we did there was start a massive change in our IT systems. When we split from HP had never really consolidated a lot of our systems. So all these divisions all over the world had their own systems. So we had 3,000 systems to run Agilent when we started, and our IT as a percent of revenue was 8%. And at that time, the industry average was closer to 2%, 2 or 3. So we went out and said, we're going to change it. So we did a bake-off with SAP and Oracle. We ended up picking Oracle. And we spent about 3 years converting all of our old systems to new vanilla. Nobody got to tweak the system for their business, vanilla Oracle systems, and took our numbers down to 2 to 3%. But at the same time, we looked at our businesses. I mentioned we were initially in the medical business, but the medical business was really struggling because the business had tried to get into the healthcare information system business and do a lot of software, but we had fallen behind on some of the instrumentation side. Meantime, GE and to some extent Siemens were going into hospitals. And by the way, hospitals were consolidating about that point, so consolidating their purchases as well as the operations. So GE would go into a hospital and say, we have CAT scans, we have X-ray, we have MRIs, and oh, by the way, we'll throw patient monitoring or cardiac ultrasound in for free, which, by the way, was our businesses. So we were getting not getting the opportunities to compete. But then GE further said, oh, by the way, we'll finance it for you, and we'll do a service contract on the whole thing, everything. So we either need to double down on CAT scans, X-rays ourselves.
Now, you were making CAT scan?
No, we weren't. No. That's where GE was. Yeah. GE was doing that, but they were competing against us in hospitals by selling hospitals those things.
Like the cardiac ultrasound.
And then they throw in the cardiac ultrasound for free.
Okay, got it.
So GE was making CAT scans. I understand. Yeah, and so we either needed to go do the same thing they were doing, or we would have to sell the business. So we ended up selling the business that first year to Philips, and they already had CAT scans and X-ray and MRI, so they've done very, very well since they got our thing. So
there was a place just down the street here called Acuson.
Yeah, that became part of. I think it became part of Philips. Yeah. So anyway, we ended up. It was either GE or Philips, I don't remember. But we ended up selling that. We got the cash for it in 2001, which turned out to be very fortuitous because that's when our business collapsed, when the dot-com bubble burst. So we got a couple $2 billion cash infusion just about the time we really needed it.
Now I'm curious. I understand why computers would be affected, but why instruments? There's just a general cash crunch for people, or no one investing anymore?
No, a lot of the business growth we had seen in the late 90s, early 2000 was from the broadband, mostly optical build out that Lucent, Nortel, Alcatel, all these telecom companies, they were installing fiber like there was no tomorrow. And then there was, at the same time, a lot of semiconductor devices that were used in broadband applications. And so the whole industry pretty much collapsed. I mean, our revenue went from roughly $3 billion a quarter in the second quarter of 2001 to 1.3 billion, or from the fourth quarter of 2000 to the third quarter in 2001, where it was about 1.5 billion a quarter. So it dropped almost half, or even a little more than half, is about 60%. And at that point, we had only 500 million of cash in the bank. HP figured we were good cash generators, so they didn't need to give us a lot of cash. So we ended up getting not enough cash. So this windfall from selling the medical business was really critical to keep ourselves afloat during that tough time.
Tell us about that, the medical business, and what they made and what you sold.
So it was primarily the patient monitoring and the cardiac ultrasound. HP had bought a company called Sanborn a number of years ago back in Boston, and that was basically their business, and we built it up as our medical products business.
Okay. And who did you sell the business to?
Philips.
Philips.
Yeah.
Got it.
And I took over responsibility for those businesses in 1997 or 8. So I was managing all of those medical, analytical components and the test and measurement when we announced the split. So all 4 of those ended up in Agilent. And then the medical business, when we sold it, people asked me, well, what are we going to do with the money and what are we going to do next? And that's when I said we're going to invest in life sciences. So we introduced something that was in our HP labs called a DNA array that was actually built on a printer, bubble chip. The way they built the printer chips was with the bubbles, and they could put DNA on a chip the same way they put ink on a chip. And so we introduced that in 2001, I think it was. And then we had a lot of other.
How did that product do?
It did very well. Still going, did very well. And they've expanded it.
I think Affymetrix is the big competitor.
Yeah, I don't know if they're still around. I mean, I haven't heard much of them lately. I think HP and Illumina, I think, was the other one who had some products in that area. But we also doubled down on mass spectrometry because turns out a lot of drug discovery uses mass specs. HP had underinvested in the late 90s in mass specs, so we put a lot more money into mass specs in the early 2000s, and that's really taken off.
I can tell you an interesting story about that. I was visiting the National Museum of Science and Technology in Ottawa, and they have a restoration lab, which is a beautifully government-funded restoration lab with a HP GC mass spec.
Oh, was that right?
Right, which they used to they put samples of paint from a really old painting or something, and try to see what kind of pigments they used. And so it's fascinating. There are many applications.
No, in fact, so today Agilent is split again, and after selling the medical business, just about the time I retired in 2005. We had decided to sell either all or part of the component business, and we ended up selling all of it in 2006. And so what's left of Agilent is the original chemical analysis business and the instrument business, electronic instrument. Today, the electronic instrument business is Keysight, and it's primarily focused on communications testing, all kinds, optical, RF, cell phones, everything. And Agilent is now a life science company, and they're still building GCs, LCs, mass specs, but also have really expanded their whole portfolio of life science products. So Agilent and Keysight have done very, very well.
Tell us a bit about Keysight and when that split happened, and if you have any insight into how it was named. Keysight?
Yeah, actually that was after I had retired. So my successor, when he got to the point he was about ready to retire.
Do you remember his name?
Bill Sullivan.
Thank you.
Yeah, Bill Sullivan was my successor, and he did a great job. He ran Agilent for I don't know how many years after I retired. And then as the businesses kind of diverging a little bit, the Keysight was more of the traditional instrument business. You know, each little product line adds up. Each had its own competitor. The life science business almost had a different market dynamic. It had higher multiples. The market was interested in, life science was really starting to take off. And so Agilent became much more focused around that business. And
does HP make electron microscopes by any chance? Or no.
I don't think so. We didn't. I don't remember if they got into that later. They might have, but I don't know that for a fact.
Right. I think Zeiss is the big one.
Zeiss is a big one, and we use a lot of Zeiss optics in a lot of our products. But Keysight, I don't know how it was named. I wasn't part of that. I had already retired.
Yeah. I think there was probably another round of like, oh, they're changing the name again.
Yeah.
From HP, and now it's something else.
I like the Keysight name. It's a good name.
Their logo is pretty good. Yeah.
An interesting. We had this branding firm help us come up with names, and they had names all over the map. And of course, as you might imagine, some of the names didn't work in Japan or didn't work in Spain or someplace for. But I remember one of the names that employees liked. We asked employees for input. Employees were really sad to let the HP name go, so they wanted Hewlett-Packard to be our name. Well, I don't know if you know, but it turns out Hewlett-Packard is actually a barf bag in Scotland. So we decided not to go down that path.
Yeah, it's tough finding names. It's harder than you think.
So we settled on Agilent, and it seemed to work in most of the countries. And but it was an interesting process. But the employees were very sad, and one of the things that helped was HP had gone through some different experiences. Carly had come in. They were in the middle of the Compaq merger. She did some layoffs. When we did our layoffs, we did it in a much different way than Carly did. She just outsourced it to some firm that came in and told people they were fired. I had every manager talk personally to every person let go, and tell them this was not about them. They did a great job. We just had to resize the company to save the company,
I remember the valley, the whole entire valley was very depressed.
Oh, it was a tough time, but I think one of my proudest moments was when we first split from HP, we were number, I think, 33 or 34 on the Fortune 100 best places to work. And based on interviews with our employees and everything. But then in 2001, when right in the middle of our layoffs, we were laying off a third of our people, we ended up as number 35 on the same list. And there was an article in Fortune said how you can lay off a third of your employees and have them still love you. And they talked about how we went about, helping employees transition, helping them the most we can to find other jobs, giving them generous severance, treating them with respect. Because my thinking is we had to be sensitive to survivorship bias. So the people who weren't let go, they're going to look at how their buddies were treated. And if they think their buddies were treated with dignity, respect, sensitivity, then we can keep a lot of the basic HP way that we were trying to keep. But if they thought their buddies were just treated like, you're out of here, we could never keep the HP way. So that was a critical moment for us in kind of preserving the culture of HP and Agilent, is how we dealt with the dot-com bubble bursting and how we laid off, so many employees.
Mm-hmm. Where is Agilent based right now?
Agilent is now in Santa Clara. It's the old Santa Clara division where I worked.
Oh yes,
in the 70s.
Science fair division.
It has a moat around it.
Oh really?
Yeah, there's a moat around it because the general manager, first general manager was a sailor, and he used to like to race little
radio control
boats in the moat.
Oh, that's fun. Well, let's see. So you've been retired for 20 years now?
Well, I retired, but I never really retired.
Okay.
After I retired.
Tell us what you've been doing.
Okay. Yeah. Well, first of all, I always thought maybe if I retired, I'd just stay on the board or become chairman or something. But my board talked me out of that, and I'm so glad they did, because I think as long as being the founding CEO, people would still go to me. It wouldn't be fair to my successor. He needed to do what he needed to do, and I didn't want to be looking over his shoulder all the time and second guessing him. And he did a great job. I was very happy, but I might have done a few things differently, but it doesn't matter. So I think that was one of the better decisions I made, and the board encouraged me that was probably the right thing to do, and I've preached that in my other boards that I've been on. So I did.
Sorry, when you say board, this is the Agilent board or the HP board?
This was the Agilent board.
Okay,
yeah.
Thank you.
So when I retired in 2005, I was chairman of the Agilent board. So and I've been on the board, but I've been chairman for 3 or 4 years.
So you were chairman, president, and CEO. I think.
At Agilent. So so when I retired, I started looking around. I looked at doing something in venture. I looked at something in private equity, and I just couldn't get excited because all of my career had been working in a bigger company, building cultures, helping companies succeed for the long term. And I got the feeling that venture and private equity was trying to spin things and sell them in 7 years or whatever, and I just couldn't get excited about that. So I decided I would go on boards, and I wanted to learn something about, I'm a hardware guy, so I wanted to learn something about software, so I went on the eBay board. Meg Whitman contacted me. I was lucky, I had a lot of board opportunities. So I picked eBay, and then, because I wanted to learn something about the internet too. I also wanted to learn something about software, so I went on the Adobe board. Chuck Geschke, John Warnock were friends, so I went on their board. And then I decided to stay on the KLA board. That was kind of my home base of hardware. So I had been on that board. I went on that board in the late 90s. And I just retired from that board last year or the year before. I've been on the board over 20 years and I was chairman for 16 years. So I was chairman from like 2007 to when I retired.
How's the workload with these boards?
Well, the workload was I was working hard, but I also joined some nonprofit. I joined the board of the Packard Foundation, which actually took a lot of time. And I did that because I wanted to give back. I had a lot of opportunities in life because of Bill Hewlett and Dave Packard and HP. So when the family asked me to go on the Packard Foundation board, I decided I would do it, but I ended up spending a lot of time there. I set up their investment function. I was on the executive committee, comp committee, so that was a lot of work, but I enjoyed it. And I did that until a couple of years ago as well. I think I was the longest serving general non-family trustee. So anyway, I was on a couple other nonprofit boards, and I was pretty busy. I would say, and I wasn't just on the boards. I was chairman of comp committee or nominating committee or lead director or chairman, or yes. I was pretty involved.
Demanding positions.
And I ended up, helping a lot of these, companies. Adobe's just been terrific, but I was involved with the selection of Shantanu Narayan and getting them going. And I remember he was asking, "What do you want me to do?" I said, "Well, everybody seems to be working on something related to mobile, cloud, social media. We're not doing any of that. Isn't there a way to figure out how we can get involved in some of these things that are going on?" So to Shantanu's credit, he came back with the whole board talked about that, not just me, but, came back and said, "I think we ought to go with the subscription model." And then he ended up buying a data analytics company so he could help people monetize their content they were generating. So it just kind of took off from that, and now Adobe's $20 billion software company, so it's doing very well. So I've really enjoyed my boards. eBay, we bought PayPal shortly after I joined the eBay board, so I was involved with PayPal, eBay, Adobe. KLA's been amazingly successful, even recently.
Just because I have a personal interest in steppers and photolithography, do you anything interesting about KLA and ASML, I guess, is their big competitor?
Well, ASML has, they pretty much own e-beam lithography. They made a huge investment. They bought a little company in San Diego, they integrated it, And at one point, they've invested, I don't know how many billions of dollars, but they're the only game in town for E-beam lithography. An alternative to E-beam was overlay. And, we competed a little bit with AMSL in some of the overlay things. But I think we've kind of found our space, and they've found their space, and their space is clearly E-beam, at least as far as I know. They still sell some of the things that KLA does, but I think KLA is doing pretty well in the overlay area and the in most of the inspection areas that they're in. They have a really good position in all of the inspection areas, E-beam inspection, et cetera.
Right. I'd like to touch on the HP Labs and its role in product development or supporting the business.
I think HP Labs was HP's secret sauce. If you ask me what made HP great when we split off Agilent in 1999, HP had been around for 60 years. And during that time, it grew 18% a year. So question is, what did HP do right over 60 years to grow 18% a year? And I'd say it's three things. One was a decentralized management structure, management by objectives. Decisions about what businesses to get in didn't come from Dave and Bill. They came from the organization within. I mentioned this divisional structure, this kind of viral structure we had in the instrument area. The original ideas for inkjet printers came out of HP Labs. And so a lot of the ideas for businesses just came virally out of the organization, not tops down.
Sorry, I'm just going to ask how results of HP Labs were communicated to the rest of the company.
Well, that was always a challenge, but I think most people knew. Let me just finish, because the first thing was the culture of decentralization. Second thing was the culture about hiring and training best people, hiring the best engineers, and letting them innovate. But the third secret sauce was HP Labs. And managing HP's labs is hard. We took basically 1% of all our R&D budget and gave it to HP Labs and told them their job is to look over the horizon. What are the things the businesses aren't paying attention to? What are the new technologies coming along? What are the new unmet user needs that are out there that we haven't been able to address? So the labs kind of kept the businesses honest over time. And so in instrument part, they were terrific. I mean, that's where we got all of our leading edge components. I mentioned our gallium arsenide technology. Initially, it came out of HP Labs. A lot of the work in thin film came out of HP Labs. Some of the really high frequency microwave circuitry. But even on the computer side, the inkjet printers came out of the labs. A lot of the early work in networking. I think the HP RISC architecture started in HP Labs, migrated to the business. So I think the important thing was the businesses need to acknowledge the role of the HP Labs so that businesses valued the labs. I think that's not the case today, or at least not. I think there was a change over somewhere in the last 10, 15 years at HP where I'm not even sure there is an HP Labs anymore. But I do think it was important for the businesses to be clear and acknowledge and look at the labs as a real strategic partner. I mean, I know when I was running a business, I would meet every 6 months with the lab and say, "What are you working on that's going to affect me?" And if every division did that, they're getting bombarded with stuff and they have to pick and choose. But very often they pick and choose the things that were the most interesting technically or the most interesting from a business point of view. And I'd say they're right more than wrong.
So there was a sense of importance. There was a bottom line driven motivation to some extent at HP Labs.
Yeah,
it wasn't a pure research just for the sake of research.
No, that's where HP was really unique in that way. I think Bell Labs was maybe a little more research for the sake of research. And we wanted to be really careful not to have the labs designing the power supply for the next computer or something, because there's a lot of people in the divisions could do that. So I think that we tried to find the right marriage of doing things that the businesses either didn't know how to do or didn't have the budget to do, but were really critical for the long term, and keep the labs focused there, but not blue sky research. We didn't do a lot of blue sky research. If anything, the labs had relationships with the Stanfords or MITs or Harvard or Cornells of the world to do that blue sky research, and not the labs. So we tried to keep it aligned with technology, and I would say by and large it was pretty successful. And once a year we'd had a review. All the businesses would have a review of the labs, what they're doing. Bill Hewlett, Dave Packard would come in and have a review of the labs. I when I was CEO, I'd spend probably at least half a day a month touring the labs. They really appreciated me taking an interest in what they're doing, and I'd come over and say, "Show me some stuff you're working on. This is one of the best half a day a month I had." So I think you can do a lot to make them feel important, and there wasn't a specific metric as to how many dollars they generated, because I think that's so hard to do. Because sometimes they would turn something over when it was half baked, and then somebody else would have to finish it. So where's the innovation? Is it the guys that finished it or the guys that started it? We tried not to get bogged down in metrics for the labs, but everybody knew, when critical pieces of technology came from the labs.
Yeah, like the laser printer and the inkjet.
Inkjet
as well.
And again, the HPA risk, everything.
I wonder, were there any giant successes, like a product that just lasted decade after decade that HP could still keep making? Or do they pretty well, nothing really lasts that long anymore?
Well, I mean, I'm amazed. The HP calculator. The HP calculator came out in 1971 or 2, HP 35, and I think HP is still making calculators. That's another interesting story. Shortly after HP came out with the calculators, maybe a couple years later, TI and others started coming out with 4-function calculators that were a lot cheaper than the HP 35. And originally HP started chasing these folks down. And that's when Dave Packard came back and said, "No, we're not going to build new me-too products." So we went the other way and started putting more features and functions into the calculators. And so the HP 12C and all those derivatives are amazing. I mean, and those are still around.
And one story I heard about Dave Packard was that he wanted to show how the calculator fits in his shirt pocket, but so he had to get a special pocket, a slightly wider than normal pocket. Is that true?
Well, that was Bill Hewlett.
Oh, yeah, Bill Hewlett. Yeah, what did I say?
Dave Packard.
I'm sorry.
So yeah. Bill Hewlett was kind of, if there was a father of the pocket calculator, it was Bill Hewlett. He said, "I want one of those." He pointed to a computer. He said, "I wanted one of those that would fit into my shirt pocket." But somebody jokingly made him a big shirt pocket. But
that's the story.
Yeah,
okay.
But the big one, but the one we actually introduced did fit in a shirt pocket. Yes. So the HP 35 did fit in the shirt pocket.
Possibly one of your most successful. Yeah, I mean,
and it stayed around forever. And again, if you look at a lot of the products are different today, but they're still the same in concept, but the technology has moved. So if you look at one of our spectrum analyzers today or our network analyzers, it's not that different than what we did in the 60s and 70s. It's just that it's working at 40 gigahertz instead of 3 gigahertz, and it's got so much more accuracy and so many more features. So, there's a lot of that still goes on in the instrument side.
One thing I wanted to bring up, which is, I know, not the happiest topic, but Itanium. And can you tell us a bit about that chip? And Hewlett, it was they hitched up with Intel, I believe, right?
Yeah.
And that went on for a very long time.
Yeah, somewhere in the mid. I really don't know a lot about that. Yeah, I was running the instrument business at that point, but this, I know because I was on the executive staff that we were looking at do we design what's the next generation of the HP PA RISC? It was our RISC architecture that we'd introduced in the late 80s.
Ruby Lee, I think, was one of the key
designers.
Well,
Joel Birnbaum. Have you?
Yes, Joel.
Joel was the one who actually brought RISC architecture from IBM to HP, and he came somewhere in the 80s, early to mid 80s, and so we built this RISC chip, and then the question is who builds the next chip, and at that point Intel was trying to figure out what they do next, so they thought maybe they'd want a RISC architecture that could potentially be a more broader, successful consumer product. So I wasn't involved in the meeting, so I don't know how it all came about, but there was an agreement between HP and Intel to co-design for some period of time the next PA RISC chip called the Itanium. And I honestly can't tell you why it failed, why it didn't come out, but
I believe the consensus is it was the software. It had trouble writing the compilers.
Yeah, it might have been, yeah.
Which, RISC stands for relegate the interesting stuff to the compiler.
Oh, is that right? I didn't know that.
Well, not officially, but yeah.
So
that's where it fell apart, I think. Yeah.
Yeah, but it was one of many things that Intel failed at. I mean, they back in I think it was in the late 90s, early 2000s when Craig Barrett bought a bunch of optical companies and wanted to be in the optocoupler business and stuff. And I knew that because we were in the optocoupler business, but by the way, what we sold off as our component business started as an optoelectronic, all the light emitting diodes in cars, optocouplers and things in computers and communication systems.
I remember HP had a very nice 7-segment display.
Yeah, we had a really nice display.
It was very easy to use and big and bright.
And so that business that we sold off is now the core business of Broadcom. So we sold it to a venture firm and a couple venture firms, and then they rolled it up with some other companies to make what's today Broadcom. And I don't know if they still make optoelectronic devices, but we kept in Agilent when we sold it. There was a business. There was a project to make white light, and so we formed a joint venture in Agilent with Philips because we didn't have access to the consumer market, but we had access to the technology. So together with Philips, we invested for a number of years in a products to make white light, and that was eventually spun off as a separate company called Lumileds, and Lumileds was right here in the valley.
Yeah, how do you make white LEDs?
Well, it's
combine RGB ones.
It's different. It's a different formula, and you have to combine, the RB, the green and blue and reds in a different way to make some white. And but anyway, I was excited about that because the whole idea of replacing incandescent lights is pretty exciting.
These are all LEDs.
Yeah, but I don't even know if Loads is still around anymore, but that was a fun business. But we did have that in Agilent for a while.
Yeah. And in terms of success, was that used internally at Agilent, the white LEDs, or did you sell them as components?
No, we used them. The problem was they were expensive. You had to get the cost down. We made white, but white had to be cheap. And so we used them in some applications where, like in a stadium, where you didn't want to, you didn't have access all the time to the lights up in the stadium lighting. You might use them there because you wanted things that lasted a long time. Yes. So it started off in high maintenance applications, and then as the price came down, it started finding its way more into the mainstream. And I think today it's more in the mainstream. So.
Right. I had an interesting thought. Did you ever meet Fred Terman?
Not really. I saw him around when I was there. I knew him. I knew of him, certainly. I read his book, or I had his book in class.
Yes, his textbook.
Textbook.
Yeah.
But no, I think he might have been provost when I was there in the early 60s, so I didn't see him very often and didn't pay a lot of attention to that.
Just the links with HP are so close with Stanford. And
yeah, no, I ended up, later on, after I moved back from Spokane, I ended up becoming the assigned executive to HP, from HP to Stanford. So I worked with, there was a Dean Pettit for a while, and then there was another Jim, after Jim Gibbons, there was another one. I worked with Jim Gibbons, but another one. And then, and I'll never forget, somewhere in the mid-90s, Condi Rice became provost at Stanford, and I gave her $50 million worth of computers as the assigned executive. Lou Platt was with me, but I negotiated and was able to facilitate a pretty large grant of computers from HP to Stanford. So I got to know Condi pretty well in that period of time. So the ties between Stanford and we've always, again, encouraged our engineers to take classes at Stanford. A number of our engineers have been on the engineering advisory board. And so it's and a lot of our engineers, some engineers teach over there, some engineers, we take some of their faculty over as a summer fellow or something,
Yes.
where there's just a lot of back and forth with Stanford, which is great.
Yeah. Do you think the HP way survives?
I think so. I haven't been close to, certainly the HP companies. I've been not close at all for 20 years, 25 years. So, but at least on the Agilent and Keysight side, I do think there's a lot of the HP way that's still there. And at least I read about it. I hear them saying all the right words about, trust, respect, teamwork, integrity, contribution, community, all the words that I think are really important to maintain the HP way. So again, I can't say for sure on the ground if employees feel that. I just haven't been close enough to it to know, but I would hope so, because I just think there's so much value in it, and so much value in leaders. Basically, there's a lot of different leadership styles. There's the Steve Jobs style, there's the George S. Patton style, but the Bill Hewlett, Dave Packard style of roll up your sleeves, get involved, value your people, trust your people, build a team that works well together, that kind of servant leadership style. I just think is such a great leadership model. And I saw it practiced around the Valley, but nowadays, I don't think some of the newer leaders are what I would call servant leaders. Certainly some of the Musks of the world or the Zuckerbergs are coming different. They didn't grow up in an HP, so they didn't grow up with a leadership model like that or built on something like the HP way. So
Or some might argue even a good moral foundation.
Yes,
That's another story.
Right. No, I think that a lot of that comes back to this notion of always do what's right. I mean, Dave, there was a lot of times when we could have taken a shortcut to get a government contract. We could have compromised. We could have done some things we didn't want to do. But at the end of the day, we always stepped back and said, just do what's right. And that, to me, is a great model, a great role model for business to think about that.
And life.
And yeah. So I feel very fortunate. My years at HP and Agilent were great years for the electronic industry. Saw a lot of growth, a lot of new technologies. Saw computers rise, saw printers rise, PCs, saw the internet, saw cloud computing, saw all kinds of stuff. And it's just now AI, to me, it's just exciting. So I feel very fortunate to have been there at that time in the industry, but I feel especially fortunate to be in HP in that time to be able to help make a lot of that happen and to see the inside out kind of the significant changes in the world that we help facilitate.
I think HP arguably was the most desired company to work for decades because of the way it treated its employees, the respect for the engineer and other roles. And just really, like you say, respect. Yeah. And I wanted to ask you, this as we wrap up here, is there anything you'd like to say, maybe looking forward, or if you had any words of inspiration for youngsters who might be thinking of a career in engineering kind of things?
It's interesting. And when I look back at my career, there were periods of time where it appeared like the technology had run out of gas, kind of plateaued. I remember, I think it was in the 90s sometime that Intel was talking, we're getting close to the end of Moore's Law, that people were worried that all the great innovations have already been made, and then boom, along comes the internet. And so I just think, it's interesting to see these plateaus, and you can kind of get a little down and wonder what's going to happen. But you can also roll up your sleeves and say, what can we do to change that? What can we do to take advantage of the foundation we built to build something new? And so today I'm as excited about AI as I was from the day I first joined HP thinking about transistors. Transistors for me were transformational. Of course, ultimately the integrated circuit was transformational, but so was the internet, so was the cloud, but now AI. So I just think there's so many exciting opportunities ahead. I just encourage all the young people, think out of the box, think about all the things we can do, and try to be responsible about what we do, because I think there's a dark side to a lot of these things as well. But make sure we're taking advantage of what the goodness offers, and make sure there's a lot more goodness in the world than the bad side, and it'll be successful. So again, I wish I was starting my career over, because I think there's so many exciting things to work on. But I'm happy, that I feel very appreciative of the opportunities I did have in my career in life. And again, thanks a lot to Bill Hewlett and Dave Packard.
Ned, thank you very much for a great interview. I'd like to just thank you and wish you a great rest of your day.
Thank you very much. Good.
Thank you.
Thank you.